expect, I hope. But again, this is something that is going to be very useful going forward, and especially for products and frameworks where people are implementing the interface. Yes? No, I don't think so. I don't think so. I don't think there's anything less strict about this. No, just that this contract says these things all have to be implemented. But here is an implementation of this method if you don't want to supply one. So it just means that I can provide some of the contract with the contract itself if somebody doesn't want to. This is sort of an extra piece of the contract. And so as far as the user is concerned, when I invoke this contract, it's all going to be there. It's all everything as it should be. But as an implementer, some of these things might be already optional because... I'm sorry? Well, it's not an abstract class because there's no state in it.
I think this will do away with a lot of places where we would just throw new unsupported operation exception.
Yep, it could do that too. That's easily a common use case, I think. If you say if you don't implement this, throw an exception. You can do that. You can put any code you want in this method, and it'll just be invoked when the user doesn't implement. I don't think so. This is just a default. It's not sitting there. You won't inherit this from anywhere. If it's actually supplied by the user, that's the one that gets used. So there's not two branches coming to the same place. There's just this default sitting here, and if the implementer here, if the implementer provides it, it gets used. If it doesn't, it just uses this kind of supplied default. Mike? Yeah. No problem. Yeah.
The instance, the actual instance inheriting this, it may have some other variables that it wants to use, but as a default, it should be using whatever is already available without the instance.
Yeah. So again, this is not. It's not inheritance is kind of maybe not quite the right word, but I understand what you mean. This method has to follow all the same rules. Nothing changes in terms of the contract. As I define this method is valid. It's got no parameters and a Boolean return type. Those same restrictions and everything have to occur both in this method and in the subclass, in the implementing class. Okay? It'll free up the API developers to add methods to their interfaces as their interfaces evolve. Okay? As long as they can provide a suitable default method, then they can add the method to the interface. Okay? Okay, so let's move on to the real purpose of this talk. That gives you a flavor of some of the other major features. I think those are the two, the Lambda expressions and virtual extension methods as a result of that are going to be substantial, but I know that other people have talked about that. I want to tell you about modularity. That's what I spend a lot of my time doing. People probably have seen unmodular systems. You probably work in them regularly. These are just symptoms of an unmodular system. There are people always afraid of breaking things because if they pull one thing here, then something else pulls out there. And they don't understand everything. It's too hard to decouple things. The build problem is similar. I think that's usually where people bump into this, is at build time, because the dependencies aren't well known. They're not declared anywhere. There's this POM format that Maven offers you, but that is not a code level. That's really only a build level thing. And so that doesn't actually get brought across to runtime. So Maven doesn't solve the problem. The problems are those real problems of coupling and the lack of cohesion. When you want to have highly cohesive modules decoupled from each other as much as possible. And that provides you the code to be reused across different areas and in different applications. The whole idea of off-the-shelf components has been around for decades, but it's not really been realized, to be honest. And I think it's because, at least in Java for sure, we haven't really had this concept of modularization. We've just had this very unmodular jar, which is just really a container. It's nothing really to do with modules, as it were. It's not part of the language. So these are all good things, all motivations for having modular systems. So what is a module system? There's metadata, these modules here. Every module has identity. It must be unique, in a sense, or it's the same module. If it's not unique, then it must be the same module. It has to have some sort of packaging around it. And there's some metadata that is accompanying the module to tell the module system what to do, what the constraints are. And then there may be other dependencies on other modules. So all these put together form a module system that controls and enforces all these dependencies and constraints. The runtime is when it actually happens, normally in a module system. As we'll see, Jigsaw, it happens at more than just runtime. It happens at build time as well. So it'll check all these things at compile time and install time when you install libraries. But at runtime, the jobs are that you have to actually resolve or potentially resolve these modules if they haven't already been resolved. You have to make sure that the modules don't extend beyond their boundaries so that you can't load classes from modules that you haven't said you depend upon. And class loading is a big part of a module system. Now, the line is the class path is going to go away, that there will no longer be a class path in Java. In reality, there will be class loading, a whole lot of it. In fact, class loading may be even more important now than it ever was, because modules have to be implemented somehow. This enforcement has to occur, and the way that it occurs is through class loading. That's usually the way this isolation is implemented. So if you're within a certain module and you're loaded by that module's class loader, and you don't have access to other class loaders for other modules, then those other classes will be isolated from you, and you shouldn't then be able to access those class loaders. Yes? Well, I'm glad you asked. I'm going to tell you what a module is. The module system manages modules. In Jigsaw, so we'll talk about Jigsaw, Jigsaw is the project that is implementing a module system for Java SE8. It's essentially the prototype for modularity in Java SE8. The JSR is going to be starting soon, and that will also govern and control some of the output of Jigsaw. But Jigsaw is currently what we have and what we're using to prototype a lot of this stuff. It was actually created to modularize the JDK itself. This is why Jigsaw started. The JDK was getting big, and it was kind of a chunk of stuff. And it was very, I think, it certainly was coupled in that everything kind of had pointers and dependencies outward. But not only that, it was packaged together. You had the JRE, and that's what you got. You loaded it or you didn't. And if you used swing or didn't, you got it. Right? So this was the problem. And Jigsaw was attempting to carve the JDK into pieces that were consumable separately. And so that if you don't use Corba, well, Corba is this other module that you never load. And you don't even have to, put it on in your system. It just won't even be there. So JDK being modular means a couple of things. It means that Jigsaw module system that's used can be used externally by applications. Right? Applications can now have a module system that they can write modular code with. And the second thing is that the JDK itself will be separable, much like Java ME allows you to have a smaller runtime. Well, it'll be customizable now what your runtime is, because you can select the modules that you consume and no others. So in that sense, it provides us a dual benefit. The one thing about Jigsaw, how many people here have used OSGi as a module system? So like 2 or 3 of you. OSGi is a module system. In fact, it's the only real module system available right now, but it is designed for a very dynamic environment. OSGi was originally designed to allow for gateways and for devices for these things to come online and go offline. So these services were very mobile and only sometimes present. And as a service came, then it would register with the system, and other consuming devices could make use of this other service. And then the service might go away, and it would look for another service that offered the same kind of features. Well, it had modularity, but it also had all these other service layers and lifecycle layers and a number of other complexities that made developing an OSGi quite difficult. And so as a result, it reached a certain amount of popularity within probably more the embedded community or mobile spaces. And so it hasn't really taken off in the enterprise much. I've been working on it in the enterprise the last couple of years, and although it's been possible to do this, it has been quite challenging. Jigsaw, on the other hand, is quite different from OSGi. It only does the module system. So it's taken the very simplest and basic part of what modularity is about and tried to implement that. As a result, there are some, I would say, shortcuts that Jigsaw is taking that could end up being a little limiting in some respects, but it's got a certain target. It's got a certain goal and expectation, and that's what it's going after. And the win for that is that it becomes much easier to use. And so as developers, we are able to pick it up a lot more quickly. That's the hope. But a static environment is a key difference between Jigsaw and something like OSGi. Right? And it does have services, but it's really not services in the way that OSGi supports services where you register a service and it's very dynamic and you could be any implementation and it could come and go at any time. It's more like the meta-inf services, if everyone knows the meta-inf services model, where you have a meta-inf services file, and in that file is the implementation class. The file is named after the interface class, and then the service loader goes and loads this services file, and then knows what the implementation is and goes and calls it when you ask for all the services. So that's how the service loader, that's how Java works now with services. That's kind of what you're going to get with Jigsaw. All right. Other things, we asked about modules. Every module has identity and versioning, I mentioned. Well, the identity must be unique, and so identity means a name and a version. If it hasn't got a version, then it may not be unique. It probably isn't, because another named module, as it evolves, will have to be reversioned to a different version. And the ampersand or @ sign is used to separate the two in syntax when you specify it somewhere. Okay? And by convention, the name is the kind of the primary package name or some domain name or something like that. There's no real versioning. OSGi has something called semantic versioning, whereby the dot notation of the version implies certain things, and a certain dot in the location means it's compatible, in different ways, whether it's client or implementation or whatever. So this has none of that, but it does have ordering. That's pretty much all it has. So 1.1 is greater than 1.0.1. The packaging of a module is important in that you have to be able to pick the module up and copy it somewhere into a directory or wherever. So in the past, people have used jar files to contain code and resources and classes. And so jar files are actually going to continue to be able to be modularized by adding metadata to them. But there's also a new format called the JMod format. That's going to be the module format, and it's native. It's created using a new tool called JPackage, or it can be created just through the JavaC compiler. The JMod format is again, it's unique. It's not you can't just open it using zip or some other zip tool. So there are going to be other tools available for introspecting and finding more about the JMod modules. The Jigsaw is being built right into the JDK. So this will be in the core. It's not going to be something that you plug in. No, I see what you're saying. The modules themselves are like plugins. Well, yeah, except that in Eclipse actually uses OSGi. And that's the way it achieves this plugin. And in the sense that OSGi allows dynamism, and you can dynamically add a plugin, like that's the OSGi that permits that. Jigsaw won't be as dynamic as that. It's a very static-based system, so things are already resolved when you go to start your VM. When you say Java Go, it pulls them from module libraries, and things have already been resolved at that point. So there's a little difference there, yeah. Yeah, so the question is, can you load based on particular libraries and restrict the modules that might be visible or accessible, right? That's your question? Yes, and that's true. You can specify certain libraries to be used when you start the Java command line, and that would restrict what you can see. Yeah. All right, so here's an example of a module. It's got a bunch of classes and resources plus the metadata, which is called a module info file. The module info is actually a Java file. It's .java, but modules must be there in order for me to execute. In fact, in order for me to even compile. Because remember, there's full fidelity across compilation and runtime. Okay. Is what? Oh, the question is, will it remove the import functionality? No, Java classes will still import classes as they are, or packages. Well, again, it's a different level. That is a namespace issue, really. This is a class loading issue. Okay, so this is a runtime. Once you're at compile time with the import classes, if you run and those classes aren't there, it'll still run as long as you don't access that class. That's not enforced at runtime. A duplication of what? You're not duplicating anything.
We are saying that the form.acme.employee.payroll is again requiring util.math, util and math.
But this isn't necessarily a package. This is just the name of a module.
Same thing you would be doing in the payroll.java as well.
They're different purposes. I wouldn't say they're duplication. It's different. In a Java class, when you say import a class, you're saying I need this as an actual class in there in order to compile. Here, this is a requirement on a module. Okay, and that module may have different things exported. And I'm going to tell you about that in just a minute. Okay, and maybe that'll sort of help make the distinction. But right now, this is a fairly simple module info file. It just has two dependencies on two different modules.
Does it say what this module contains?
No, it doesn't say. In this module file, you don't know. You have to know when you look at that module what it's providing you, what it's exporting. And it says in its module info what it exports. That's the encapsulation that we're going to talk about. Yeah. Yes.
Instead of generating this manually, can it be generated out of the import statements that we have?
Out of the class import statements? You could certainly come up with a tool that said, I don't think it's a correct tool because there's nothing versioned, for example, in class level import statements.
Somehow I provide the versioning detail in our Java class.
I don't know how you do that. Because on an import statement, all you have is a class or a package even coarser grain. So there's no way to know what version of that class you need. In some cases, that's a cause of errors. People import a class and they go like, what? This isn't the right, I can't find this method on this class. And it's because they're using the wrong version of the class. And there's no way at compile time in our existing import statements to identify that. Is it possible? Yes. Is it practical? No. Because we're not in the business, or it's not desirable to version classes. A class is too fine-grained a unit of reusability. Okay? A class is, in Java, it doesn't make sense to have the class as a module, because that's really what you're asking for. You're saying, give me identity at the level of class. And I'm saying, no, that's not going to be provided because it becomes impracticable very soon. Yes?
Earlier, we had the option of trying to use a different version of the library without having to compile our code, right? So we could use shared libraries with the app server had a lot of features for us to do that.
Yeah.
Now, if this information has to be compiled, now aren't we saying that tomorrow, let's say if I decide to upgrade to a newer version of the library, I have to compile my application?
Yeah, so in this case you would, right? If I understand your question correctly, if now employee util was up to version 1.2, what happens to this one that's still using 1.1? Do I have to now go in here and change this and recompile? The answer is yes, in this case you would, but this isn't maybe the best way of doing it. Okay, there are rules or ways of expressing which versions you want with them being open-ended. And this is what you were asking for. Okay? So dependency constraints can be more advanced than what I've shown you in the first slide. That was a very simple one saying, I just want this version of this module. You can have ranges of modules versions. So in the first case, I'm saying this is the exact version. That's equivalent to the fourth one. It's equal to 2.5. But these other two might also be good. I'm anything 2.1 and above, so as future versions get developed. But there's a danger of that too. Because as I say, anything greater than 2.1, that's saying that if someone comes along and version 4 breaks something, then I'm going to pick that up and I might be broken too. So there's a trade-off as to what makes the most sense for your environment and for your application as well. There's also an optional constraint, which means that I will use this if it's there, but if it's not there, that's okay. I can still work. This is actually kind of tricky to do properly, because if it is absent, you have to make sure there's no references to anything in that module in your code, whether that uses reflection or what. You have to make sure that you can still compile and load. But it does allow this pluggability that some people want. Right? You want to be able to say, I really work as long as some particular driver of something is there for some platform, then I'm going to load it up. But if it's not there, okay, I must not be using that. I'll be using something else. And so there's this kind of low-level pluggability that is provided. Now this encapsulation deals, how's our time going? Oh, we're good. We have 15 minutes, I guess. Okay, I'll speed up. Encapsulation, yeah, I better speed way up. Encapsulation, the exports are what give you the ability to say, I'm keeping these classes private to my module, and I'm letting these classes out to the other applications that require me, other modules that have constraints upon me. Everything that you don't export becomes private. So here, if I export the public, Comactly public, then another module that requires me will be able to see that. Now he doesn't import, he just requires the module, and he actually automatically gets all the things that have been exported for that module. Yeah.
So will it throw an error at compile time, or will it only fail when?
It'll throw an error if you compile X, which has a dependency on Y, and it tries to use something in the Comactly private. At compile time, it'll throw an error. It'll say, I can't. Yep, compile time. So this, I had a culture break because normally I want to try to wake people up, but you guys are pretty awake. You've been asking lots of questions. Let me just say that beaver tail is something we eat in Canada. And they're not actual beaver, those are actual beaver tails in the middle. Real beaver tails. We call these beaver tails, they're actually just deep fried dough. They fry dough and they deep fry it in grease. They put cinnamon and sugar on it, and then you go skating while you eat them. I don't know, something we do. Yeah, and Obama, when he had an official visit to Canada, they had to bring him and give him a beaver tail to eat because it's so Canadian now, I guess. I don't know, it's kind of, nowadays they put everything from chocolate to jam and everything on these beaver tails, but the original is cinnamon and sugar. So if you go to Canada, go have a beaver tail and ask for cinnamon and sugar because that's the original. Nothing else is good. Okay, move on because we don't have time. You can also, not only can you have the encapsulation of what you don't want to escape from your module so that other people can not see it, but you can also, from the other side, say, well, who can actually see the things that I'm exporting? The things that I am letting out of my module, who's allowed to see those anyway? And what does this solve? Well, this solves the problem where I have a bunch of modules that are really system-level modules, and I want to export amongst myself about my own subsystem, my own layer of code, but I don't want applications above me to be able to see it. This happens a lot, right? It's private to a certain layer of stuff. And so you say permit, and if you permit modules to see you, then only those modules can use your exported packages. All right? So that's as simple as adding a permits inside. And then resolving, well, resolving is the process of discovering which module it is you're referring to based on what's available. So if I have in my module info.java, I have something that says, I require module X at version greater than or equal to 2. Well, depending on what modules are out there, I may get one version or another version. And so the resolution process dictates that. That's the hard work of finding that best fit to match the version of the module, the actual module that you get. Okay? So there's this enforcement that happens, and it has to happen both ways. You have the requires going one way, saying, I need these, and then the permit saying, oh, and only these guys can require me. No, class not found will be your friend. Yeah. Class not found is what will often happen. But another thing can happen as well, in addition to class not found. If you actually don't have that at runtime, the module's been removed since you compiled or whatever, then you'll get the class not found. But if you have two versions of the same module, potentially, and one version gets pulled in one place, another version gets pulled in another place, then you get an inconsistency, what we call a class space inconsistency. So in this case, okay, this is module X at version 1, requires some class A, for example, requires class B that is in module Y at 1.1, and some class C prime that is in module Z. But class B also requires class C, which is an older version of Z. So what happens if class C comes up through B? What happens if class B has some interface on it that actually names class C? So that class A would be able to see class C. What would happen there? Well, you could potentially get two different classes of the same name in the same class space. That can't happen. It's illogical, as Spock would say. So what has to happen is there has to be some check or some error or whatever. And what actually ends up happening is you get a class cast exception, which is the other famous exception that you get, at least in OSGi, where you've used a class here, and you actually get a different class from a different loader in the same memory space, and then you try to look at it as the other class, and it's like, that's not the right class, but it looks like the right class, but it isn't. Do two different loaders. Class cast? Yeah, it is. It's common for the same reason, but different scenario. The reason is always the same, and that is you've got a class from a different class loader. Yeah, that's what always causes class cast. Well, not always, but that's the most common one when you think you have the same class, but you don't. Other than trying to cast a string to an integer or something like that. But that's the reason why it's going to be so popular here is because class loading is the order of the day in modularity. Like I said, modules use class loaders to enforce this consistency or to enforce this isolation, and so you have the possibility of this consistency issue arising. So you're asking me how we fix it? Well, I can't give you the answer to that. That depends on how you got there. So you have to look to see how you got the class out of the wrong loader. It may or may not, just like it can or it can't now. It can only warn you for sure when you've tried to bring that class into the other loader, and it goes, what? No, I don't think so. And that's the one it knows for sure. There are some cases where it can detect ahead of time that you've got two different versions of the same module, and Jigsaw will try to do that. But there are other cases where it's difficult to determine that that's actually going to happen. And this resolution process I talked about earlier is actually very complex. And so there are some cases where it's not going to be able to find it. Well, right now, the standard story, how do you fix this? Well, one way to fix this is if you build a wall so that class C never can get out of class B, then it'll never happen. Then you're fine, right? So if you don't export anything, or if you have nothing in class B that names class C, it's just internal always, then you'll probably be fine. But the other way, of course, is that you don't have this other version, is that you specify exactly the version. So if you specify this requires 2.3, then they'll get wired to 2.3. And the resolution can work that out. That way you're always wired to the same module version. There is going to be, I think there is, that will show all, it may not be tree form, but it'll probably be something like, here are the dependencies. And then, and then here are those dependencies and everything like that. So you'll be able to look at the dependencies of a module and probably transitive closure of those modules to find out actually what the dependency graph looks like. Because tree would be a dream, but that generally doesn't happen. It's a graph. Yeah. Class loading we talked about, so I don't have to talk about that anymore. Just saying what we already talked about, how class not found and class cast happens. Now, module libraries are also a key part of the story. Because when you have a module that you can move around, that's mobile, in the sense where you want to actually resolve to it or move it into somewhere else and ship it in production, or right, these things that you can hold on to, then you want to be able to group them together and ship a bunch of modules together. A module library becomes necessary. Just like you have Maven repositories, right? Think Maven repositories. Module libraries will be the same kind of thing. You'll be able to put multiple modules in a module library, and then they get resolved as they get installed in the module library. So it's quite convenient. There's this tool called Jmod, which manages and allows you to view module libraries. And you can create one very simply, just something like that, and then install modules into it. So the module lifecycle, as it stands, is you have a module here, some source and resources, and then your metadata. You bring it into the compiler. In Java-C, we'll take it, compile all your class file into your class files, including your module info.class, and then you'd install that compiled Jmod file, or even jar for that matter, into a module library. It will become Jmod if it isn't. And then you can now pass that module, and at Java execution time, you can go ahead and pass the module in and say, run this module. And from these libraries. And so there'll be the JDK module library with all of its JDK modules, and there'll be potentially some of your own module libraries, like we talked about before. Here's some libraries to use to run with modules in them, and then the one that maybe you put this one in to begin with. So that's kind of the basic scenario for running these things, and the story has to be complete in order for it to work. Everywhere from Java-C through to Java, with all the tools in the middle to be able to manage your modules. Do applications need to be packaged differently? Differently from what? Oh, you're talking about enterprise. So enterprise, because the jar file still works, then you will be able to put jar files as modules and specify the metadata, and it will be a module. Ears won't be modules, but they will contain modules. Because an ear, modules can't be nested inside of other modules. So there will be some modules, because you can use jars and wars and things will be modular, then you will have modules in enterprise, but there are some things that won't be modules still, like the ear. It would just really just a container of a bunch of modules. Yeah. A question over here?
How do you support multiple versions? Do you have to name the jar separately? Like the jars will have...
Right. When you saw the metadata file, the module info file, you named it, and then you also specified the version of that module. And that's reified in the module itself. Okay, by the jar
file will also be named like that?
No, the jar file will have this metadata in it if it's going to be a module. It'll have to have the module info inside it. So you'll have to add that into the jar. All right. I was going to do a demo. I've got 2 minutes. It wasn't that much. I was just going to show. I had let me see here. I had some code, which was, it's really weird. I'm only seeing some of it, I guess, because of the resolution of this. I have some code that will, how many minutes do I have? Less than 5, I guess. Okay, let me just try a couple things. Forget about this Explorer thing. Let's go into modules. I have 2 modules, mod.mike and mod.tom. See that? I put them in a modules directory. Mod.mike has a single class, hello. And that single class, I don't know if you can see that, it's got single print line, a single method, which prints out hello. Right? This is simple. Meanwhile, I've got a mod.tom module, and I've got a single file called world, a class in there. You see that? This file imports the mod Mike hello class and calls the method. It creates a new hello and calls a print hello method, and then prints another world word out. So it calls the other module to print hello, and then prints world out on its own. Well, what does the module info look like? Whoops. In Tom, I need to require the base, which is the core stuff of what you need. Right? That's the core base now. That's not all the other modules, it's just the core. And I'm requiring mod.mike, anything greater than or equal to version 1.0. I'm mod.tom at 1.0. And see this class here? That's like an entry point for the module. So you know how you can specify a main entry point in a jar? This is a way of doing that in a module. You say class, and then it'll execute that class. So it's quite similar for the Mike one. So I won't bother looking at that. What I want to do is compile it. Let's look at that compile. Javac minus module path, and then minus D modules, and then I'm specifying where those modules are in the Java files. So this introduces a new option called module path. Now it compiles. What it does is it creates in mod out two files, or two directories, mod Mike and mod Tom. Those are the modules I just created and installed. So now, and I think I'm out of time, let me just install. Oops. This installs them into a library. Oops. I can't type and I can't see my keyboard. Using the Jmod tool. So the Jmod will take the modules mod.mike and mod.tom inside of the mod out and installs into the local module library. And then the module library, I can just execute. So now I'm running the mod.tom and I'm getting hello world. Mod.tom is loading. It's going to call hello, and then it's going to print out world. Okay, so that's it. Thanks for coming. If you have any questions, I'll be around.